calculate the expected value, variance and standard deviation for the probability distribution of x shown below. Well, E of x is just going to be 2. I don't really need to calculate because we can see that the distribution is perfectly symmetrical, 0.25, 0.5, 0.25, and therefore it's just going to be right in the middle. So E of x is 2. If we do var of x, we know that that's going to be the expectation of x squared, take away the expectation of x squared. So that's going to be 1 times 0.25 plus 4 times 0.5 plus 9 times 0.25. Take away 2 squared. And if we do that, it is 0.5. So var x is equal to 0.5. And then the standard deviation of x is just going to be the square root of that, which is 0.707, correct to 3 decimal places. Now consider the probability distribution of y. And we can see 6, 7, 8, the probabilities are 0.25, 0.5, 0.25. So it is the same distribution, just moved up by 5 units. Therefore, we can say y is equal to x plus 5. We want to calculate the expected value, variance and standard deviation for y. Well, as before, because this is symmetrical, we can say E of x is equal to 7. And then if we do the calculation for var x, that is going to be 6 squared times 0.25 plus 7 squared times 0.5 plus 8 squared times 0.25, and then take away 7 squared. And we find if we calculate that, sorry, this is EY, isn't it? So EY, var y, it's 0.5. And then the standard deviation of y is the square root of that, which is 0.707 to 3 decimal places. We can see they're the same values as far as the variance is concerned. Only the expectation has changed. So, the expectation of y is equal to the expectation of x plus 5. Y is x plus 5, and the expectation of y is the expectation of x plus 5. It's gone from 2 up to 7. Now, what about the variance of y? That's just equal to the variance of x. And the standard deviation of y is equal to the standard deviation of x. So only E, or expectation I should say, changes. Now let's think about why that's happened. Because we've got our data like this, and it's just simply moved up a bit. It's still spread out by the same amount. Therefore, the variance and standard deviation, which are measures of the dispersion, don't change. But we've shifted location, and that is why the expectation changes.